Good morning guys, and welcome to today's video where I do a standalone lesson on integration. Right guys, this video was recorded on the 1st of January 2021. Right guys, before I start, I want to just say a huge thank you for everyone that has been clicking on my videos and watching my videos. I'm super grateful actually. We are getting so close to 500 subscribers. My target is 1,000 subscribers as soon as possible. So if you haven't subscribed, click that red button that says subscribe, drop the video a like, press the bell icon next to the subscribe button so you don't miss out on further videos, okay? And I'm wishing everyone a happy and healthy and successful new year, okay? Obviously 2020 has been a terrible year, and my thoughts and prayers are with everyone that has lost anyone due to this dreadful and horrible virus that has happened in 2020. Okay, I hope you all have a nice and pleasant happy new year, and obviously Merry Christmas as well, actually, even though that's a bit later than I thought. Okay, right guys, in today's lesson we're going to just go through random examples of integration and the purpose of it, okay, and then we will be doing more questions in like a separate video. Right guys, so the purpose of integration, guys, so it's the opposite process of differentiation. So integration looks at finding the areas under a curve, okay? So areas of, sections under a curve. Now, these are all indefinite integrals and these are all definite integrals. And what that means is, if it's indefinite, I've always got to put on this plus c at the end, so the integration constant. And if it has limits, then there's no plus c, okay? When it has limits, that is the exact purpose of finding the area under those particular points on a graph. Okay, so differentiation looks at finding gradients of points on a line or a curve. Okay, this is the exact opposite. So this is finding areas of things under points. Right guys, so the rule is the integral of x to the power of n dx equals x to the n plus 1 over n plus 1 plus c. So I'll add 1 to the power divided by the new power plus c. Now there's a few points to mention on here, guys, and that's that obviously n cannot equal minus 1. We will come to the harder functions when n equals minus 1, but if you're interested, when n is minus 1, I get the natural log of x, okay, but we will come on to that in the future. But we are only looking at some very basic functions for today's lesson, okay? So this is an AS topic, A-level maths. Right guys, example 1. Okay, sorry about any dirt that's on the whiteboard. I do apologise. Question number 1. Find the integral of 3x squared dx. So I add 1 to the power and divide by the new power. 3x cubed over 3 plus c. Okay, so this is plus c is called the integration constant. So if it's an indefinite integral, i.e. if there's no limits, then I put the plus c. So the answer is x cubed plus c. And you are able to check your answer by differentiating the function. So in the previous video, when I looked at differentiating that, I get 3x squared, which is correct. And then differentiating the constant just goes to 0. Okay, right, next one, guys. The integral of x to 4 dx. Add 1 to the power, divide by the power, plus c. So I get x to 5 over 5 plus c. Okay, question number 3, the integral of x squared plus 4 dx. Okay, so this is, the integral sign for integration. Dx. Okay, dx here just means that I'm doing the reverse of differentiation. So dx normally would mean involve differentiation. So that's the sign here. So it's the integral. So this is the integral, and then I always put a dx at the end. Add 1 to the power, divide by the power, add 1 to the power, divide by the power. So it's x cubed over 3 plus 4x plus c. Next one, question number 4, guys. The integral of 0 dx. Okay, so integrating 0, it becomes a constant. Okay, and then remembering that differentiating a constant is 0, so it's the opposite. So when I integrate a 0, I get a constant. When I integrate a constant, which is like I've done here, it goes to constant times x, or constant times that letter. Right, guys, question number 5. Okay, so these are all definite integrals. The integral of x between 10 and 12, adding 1 to the power, dividing it by the new power, I get x squared over 2. which is limits between 12 and 10. So it's 12 squared over 2 minus 10 squared over 2, and I get the answer to be 27. 12 squared is 144, over 2 is 77, 10 squared is 50, so 50 over 2 is, sorry, 100 over 2 is 50, 77 minus 50 gives me 27. Right guys, question 6, I haven't done the final answer, but integrating x to the half dx, I get x to 3 over 2 over 3 over 2 between the limits of 6 and 0, so I will let you guys have a go at question 6, okay, and then feedback here, your answers in the comment section, okay, and then what I'll do is, later in the day, or if not the day after, I will try and put the answer to this question here in the comment section, okay. And then question number 7, x cubed dx between 1 and 3, add 1 to the power, divide by the new power. So I get 3 to the power of 4 over 4 minus 1 to the power of 4 over 4, which is going to be 81 over 4 minus 1 over 4, which is 80 over 4, which is 20. So that is my answer to question number 8, guys. So I hope it made sense. So guys, any questions, any problems, put it in the comment section. I hope you found this video useful. If you did, please like, please share, please comment, and please subscribe. And I will see you very soon, guys, okay? Any problems, guys, yeah, put it in the comment section, okay? So this is looking at definite integrals. This is looking at indefinite. Indefinite has a plus c. Definite means that I'm finding the areas of these functions between these points. Okay. So yeah, I hope that made sense, guys.